All right, welcome guys. We're going over the unit review here. Just to speed things up a little bit, I already did a few of these and I'll just talk through them. So just as a reminder, label each element to compounds. Compounds are multiple elements chemically bonded. Elements are a single type of atom. So oxygen here, O2 is a sneaky 7, so it gets a 2. NaCl and NaClO3, those are compounds because there's different um, elements there. So it says ladle each is a product or reactant. Products are underlined here. The reactants are bolded and italicized. That would be what I start with. The next thing that it's asking me to do is to circle the coefficients. Those are the numbers that I start with. So I'm circle, circle, circle. Those are the numbers in front. And to draw arrows to the subscripts, that would be letter 3 right there and the 2 right here. Realize the G, the S, I'm just going to make that a little bit more clear. The S, and the G, those are state of matter symbols. So that takes us into number 3. What are the 4 state of matter symbols and what do they mean? S is solid, L is liquid, G is gas. Those are all pure substances. Aqueous is actually a mixture. It's a solid dissolved in water. So we call those solutions, and that's actually what we'll look at next unit. So what's the difference between aqueous and liquid? Aqueous is a mixture of a solid dissolved in water, and liquid is a pure substance in a liquid state of matter. So if I had water, H2O liquid, that's a pure substance, but if I put salt in it, that salt would be aqueous. Number 5, true or false, is acceptable to balance an equation by changing the formula. That would be like balancing this by putting a 2 by the Na and a 2 by the Cl here. That's false. You can't do that. The only way that you can balance is by putting coefficients in front. How does the law of conservation of mass show up when we balance? Since I have an equal number of atoms on the left and right, or reactant and product sides, technically I start with the same amount of total mass and end with an equal amount of mass. But the main idea here is that an equal number of atoms on both sides of the equation. That's the biggest key here. Okay, so now what we're talking about here is classifying the reactions and balancing them. So I already classified here. The first two are combustion because I have a carbon compound, carbon and hydrogen, with oxygen making CO2 and H2O. Next one, I have a metal element, an ionic compound, and Ti and Al switch spots. That's single replacement. Same thing with number 12, metal switching spots. Double replacement, 2 metals in different compounds are switching spots. And that's what I see here, Be and Ni are switching spots. And lastly, number 11 is decomposition because I start with one reactant and then go from there. Now, number 8 is kind of a tough balance. I start with 5 carbons, so I got to put a 5 here. Then I got 10 hydrogen, so I got to put a 5 here. And then I would start with, okay, now I got to add up my O's here. I got 10 O's and 5 O's. You'd be like, well, 7.5 would have to go here. I can't do that. So actually what I have to do is double. That's got to be 2. This has to be 10. This has to be 10. And then instead of having 15, I have 30. So that means I can put a 15 there to give me 30 oxygens. That happens sometimes in combustion. Next one, I got 8 carbons there, 8 to give me 16 hydrogens. Then I got 16 plus 8 more oxygens gives me 24. So I needed 12 here. So now looking here, I got 1 Ti, 2 Ti's, so I'm going to put a 2 here. 2 times 1 is 2. 2 Als, 1 Al, so I need a 2 there. That gives me 3 oxygens and 3 oxygens. Those are 1s. Remember, you could also leave them blank. Here my chlorines are equal, 2 and 2. Oxygens are not, 5 and 2. The first number I can make each of those is 10. So that's going to give me 2 times 5 to give me 10 O's there and 10 O's there. 4 Cl, so I need a 2 here. Now in this one, you see how the nitrate I have 2 of? That tells me I'm going to have to double it over here. Then I can go 2 Ags, 1 Cu, 1 Co, I'm all good. I can start anywhere here, Ni I have 2, over here I have 1, so I'm going to put a 2 here. That gives me 6 Cls. Gotta come over here and put a 3 to give me 6 Cls. That gives me 3 BEs. So I need 3 over here, 3 SO3s, and I got 1 there, or 3 there, so I just get a 1. Now the next part, I've already done a good chunk of it, and this is what the type of product problems you will see on your test will look like. How do I identify? And then I got to choose their products and then balance. And I'll come back to balancing at the end if we have time, but just to make sure that the video stays of a normal length, I'll just talk about products here. So I know this is double replacement because I have 2 ionic compounds. And if I know it's double replacement, it tells me Fe and Al are going to switch spots. Okay, so A could work there. B, Fe and Al are going together, so that's not it. And then Al and Fe. Okay, so now I have to decide what's the difference between A and C. Well, the difference is that Al has a 2 here, and there it does not. And so when Al goes with OH, what will end up right here? So I have to know the charges of those two things. Al is a 3, and OH hydroxide is a 1. That means when I crisscross, I will not get a 2 here, leaving this as my correct product. Give me 1 second. Okay, so that leaves me with this as my answer, so I'm just going to copy and paste it up here. Again, I'll come back to it at the end if I have time to balance. Next one is combustion, because I have a carbon compound and oxygen, and the products are always CO2 and H2O for combustion reactions. Okay. Next I have decomposition. My elements split up. So Fe and Cl split up in all of these, so I have to decide, do they get 2s? There's only 7 elements that get 2s. Fe is not one, Cl is a sneaky 7, so that tells me that B is my correct answer. If you look at previous notes, you can see where all of your sneaky 7 are. In synthesis, my elements come together and they crisscross to give me a new compound. So, a lot of people think that it'll be AlBr2, you just shove them together. But I have to know the charge of Al, which is 3, and the charge of Br, which is 1. So when I crisscross those, I get AlBr3 as my product. 18 is single replacement because I have a metal and an ionic compound. Ni and K are switching spots, which means B I can get rid of. So the question is, if nickel forms a plus 3 charge, will I get NiCl or NiCl3? And since Cl is a -1, when it crisscrosses with a +3, I get C as my answer. Okay, so I'll come back to balance if I have time at the end, because we still got a lot going on here. Okay, so next, this was our last entry last week. Will our single replacement reactions happen? So the thing that's in red, the element has to be higher than what's replacing. So is Zn higher than Fe? So I go down. Is Zn higher than Fe? There is Zn. It is above Fe, so yes. So it's asking me to write will happen. So I'm just going to write that right here. Is CO higher than H? So I'm going down. Is CO higher than H? There's CO. It is above H. That means it will happen. Is H above Fe? Just keep going down. There's Fe. H is not above Fe. So this one is going to be no reaction. Is Zn above Cu? Go to my list. Zn is right there. Where's Cu? Way down here. So yes, it will. The next one is iron above Cu. Fe above Cu. Yes. So both of those will happen. And the last one is Fe above H. That's what it's replacing here. So I go down one last time. Is Fe right there above H? Yep, it will happen. So there's only one reaction that will not happen. It's because H is not higher than Fe on the list. Notice here Fe is higher than H. So yep, it will happen. Okay, so you didn't even have to write products there or anything. You'll see a couple questions like that on the test. And the last part is labeling solids. So if the reaction will occur, simply circle the solid. If it does not happen, cross out the products and write no reaction. So I'm going to go through and do all of these first to identify the products as aqueous or solid. That's what my solubility rules here tell me. All acids are soluble. So for us, I look up here, do I have any acids? Acids start with H. So for us, if I see H here, oh, that it's Hg actually though. That's a mercury compound. So I actually don't have any acids. So that rule doesn't help me. Next one is all alkali metals and ammonium compounds are soluble. So if I see Li, Na, K, rubidium, or cesium from my first column on the periodic table, they are soluble, which means Aq. So this one right here, Aq. 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 Okay, so that rule helped me identify a lot of these products. And next, it says acetate, perchlorate, chlorate, or nitrate compounds are soluble. So I'm looking for any of those. That's not NO3, not NO3, not NO3, not NO3, so that doesn't actually help me. Okay, or chlorates. Silver, lead, and mercury compounds are insoluble, so these are solid. So if I see silver, which I do here, that is solid or insoluble. I see mercury right here, that's solid or insoluble. So now I got something about carbonate and sulfates left. Chlorides, bromides, and iodides are soluble. I didn't have any of those. Next one is carbonates, without any exceptions, are insoluble. So where I saw this right here, that carbonate, that is solid. Then I got something about a sulfate right here, SO4. That's right here. Sulfates are soluble except when they're with calcium, strontium, lead, mercury, silver, barium. So it's going to be aqueous unless I see it on that list. And since it's with Ba, that actually tells me that this is solid. Okay, so now I just got to finish what it's asking me to find, and then I can go back and work on balancing some stuff. Okay, so I'm going to choose my marker here. This one will happen, so there's my solid right there. That's my compound, that's my solid. Here's my solid. Here's my solid. And here's my solid. And so all these reactions happen. So it's only when I get 2 aqueous, and I'll write that 2Aq is equal to no reaction. Okay. So I'm going to pause the video here and just end it. I'm running up against my time. I will put all the correct answers for balancing in, so you can see that in the key. But just because of time here, I won't have time to actually balance them. So if you have questions, let me know. Okay, love you guys, miss you. Have a great day.